Okay, so we are now starting on page 5 of your white packet. Page 5 of your white packet, where you are recording data. So looking at page 5, we are going to begin to explore how to calculate and get to the point where we get the rate. Okay, and that's what this is kind of all about. So this reaction took place in 2 reaction steps, actually. We haven't talked about reaction steps yet, but we will soon. At some point before you finish up this part of the lab, you will need to go back to the colored page with all the directions and make sure you've read through pages 1 through 3 so that you can discover exactly what's going on in the experiment verbally, and you can also understand what is going to how do we know what happens in the reaction, I should say, when you get the purple color. So it was done in a 2-step reaction, and we have these reactants that were combined. These are just the ions of the reactant, so Ki, this I comes from the Ki, and so on. We formed these products, and then as these products were formed, we were able to produce and add the other items to get these. So it was done in 2 steps, not super important for what you need to know, other than because you really don't know that that's happening while you're looking at it, and you're not physically doing that. It's just what we call a 2-step reaction mechanism. Okay, so we're going to calculate the rate. If you recall, you should remember from the beginning of this unit, we set up a formula that looked like this. We said negative change in concentration over change in time. Remember, this negative symbol here just means that it's decreasing over time, because as the reactants are consumed, they're being used up and they're decreasing over time. So the rate we will be expressing is the change in bromate over time. That's how we're going to determine the rate. In each reaction, we took 1.5 milliliters of 0.010 molar sodium thiosulfate solution, and from this information, because we have a volume and a molarity, volume is milliliters, that's how much we put in volume-wise, and we knew the concentration of it was already 0.0010 moles over liters, or big M. We want to calculate the number of moles of thiosulfate present. Okay, so these questions here are supposed to I designed these questions, or wrote up these questions to help lead you into the next pieces, to understand how I get to the number of moles, and then the other pieces that follow. So we're going to talk about what did we measure in the lab in regards to sodium thiosulfate. So we're going to go back a few slides to the recipe, I like to call, or the reactions. Here they are. Here is where I see sodium thiosulfate. We know that we had, this represents the milliliters, and we know the concentration. So if you notice, looking particularly at experiment 1, we had 1.5 milliliters of a 0.001 molar sodium thiosulfate. So the question here then that I had just looked at says, what did we measure in regards to sodium thiosulfate? We measured 15 milliliters of 0.001 molar. What are we solving for here? If you recall, right up here, we're solving for moles of thiosulfate. Okay? And we are going to then need to understand how we can get to ion of thiosulfate when we have it in a compound. So if you look here, you should see that it's a 2-to-1 ratio, sodium to thiosulfate. So for every 2 sodiums, there's 1 thiosulfate. So that means for every thiosulfate, there's 2 sodium ions and 1 thiosulfate ion. So we can set up ratios as such. 2 moles of sodium 2 moles of sodium ion per 1 mole of sodium thiosulfate. Similarly, we can do that same thing for the next piece. We can say, in this equation, there is 1 mole of thiosulfate ion per 1 mole of sodium thiosulfate. 1 thiosulfate per compound, 2 sodiums per compound. So, a little bit redundant in the next 2 questions, but I'm trying to get this information to stream through so you understand. What is the concentration of sodium thiosulfate in the reaction? We know the concentration, it's the number next to the big M, right? Because that's what the big M stands for, is concentration, is 0.0010 moles over liters, or big M. And then what is the volume? Well, we know the volume is 1.5 milliliters. And then we want to know, during the reaction, did the volume of sodium thiosulfate increase, decrease, or remain constant? So we need to go back and look at the recipe, because if it changed, we'd have to do different calculations per change. So we're going to go back a couple clicks here and right here, and we're going to see that, look what happened here. The constant the volume was constant. We constantly, every experiment we did, every experiment you did, you should have added 1.5 milliliters. Okay, so we can answer constant for that spot. Okay. Now, we are going to then create a work here. So you should see this in your equation. We're going to start with the volume of sodium thiosulfate, and we started with 1.5. So we started with 1.5 milliliters. That's up here. Let me get my marker working. That's right here. So we're going to have here 1.5 milliliters of sodium thiosulfate. So that's what you're going to put there. And then you're going to show all of this. All of this needs to be written out just like you see it. Just like you see it in your lab sheet at the bottom of page 5. Well, pardon me, not quite the bottom. It's just below the second hole punch, or just below about halfway. So you will need to change this right here and put the actual value in of 1.5 milliliters. We're going to have milliliters cancel with milliliters, liters cancel with liters, moles cancel with moles, and we get to convert, because of this ratio that we established up here, pardon me, went to the wrong spot right here, we will be able to get from volume and molarity, and get into moles of thiosulfate like we were trying to find. Okay, continuing on down page 5, you're going to then do this piece next. Okay, the color blue begins to appear when all of the thiosulfate ion is consumed. So as soon as all the thiosulfate ion is consumed, we start to see the blue or purple color. So we are going to then figure out, answering this first question, in which reaction do we see the ratio of I2 to thiosulfate? Okay. You're going to make this grid on your paper, your own grid, and you're going to bring the number you just calculated up above from the first calculation to this spot right here. And then we know, based on the fact that we're looking at reaction number 2 right here, we know the relationship between thiosulfate ion is 2:1 to iodine. So 2 moles of thiosulfate right here per every 1 mole of I2. And then we can relate the second reaction to the first by looking at the fact that we know 3 moles of I2 would be set equal to, or can be in a ratio to, 1 mole of bromate ion. So that's how we got the 3:1. So these relationships, any of these mole coefficients, can be used as a ratio to the other to get where you need to go. So now you're going to put in this number here, again, will be the number that you just calculated up above. And then you're going to go further and calculate the next piece. You're going to show all of this, all of it, on your paper at the bottom of page 5. Now this says check this page with instructor before going on to next calculation. We're going to do that in just a moment via listening to the video number you should get. Or listening to the video for the number you should get. Apologize. Okay, here we go. Hold on just a moment. Okay, you should have gotten 2.5 times 10 to the negative 7th moles. So please flip your page now, paper now to page 6, and let's calculate that value. So what did we just calculate? Remember, if you go back just a little bit, we just calculate, this is going to cancel with this, moles of I2 is going to cancel moles of I2, and we just calculate moles of bromate. And if you recall, we want to know the change in the concentration of bromate ion. That's what we're focused on. So here we are, bromate ion. To get the concentration, we need moles over liters. We just calculated these moles, and now we got to figure out where this, I want to show you where this volume comes from. So if you go back all the way back, so I'm going to go back lots of clicks here to the beginning, we combined all of this into a single test tube to show the reaction, then waited for the reaction to take its place and stopped our time. So this is our total volume. That means that all of this needs to be present to figure out the concentration of this when it starts to change. Because remember, in order for it to get that purple or blue color, all of this had to be in the test tube. If it was just this, you probably didn't get the purple or blue color. Should not have, at least. Okay, so let's go forward a couple clicks here. Back to where we were. Oops, too far, sorry about that. So we're going to take and add up all those volumes. So that means we're going to take, if you're looking at your page 4 of your colored paper, 3 plus 6 plus 3 plus 1.5 plus 1.5 plus 3 gets us to 18 milliliters. So we know we had 18 milliliters, and if you recall, there's 1,000 milliliters in 1 liter. That's how I'm getting that number there. So now you're going to place that number there on the top of page 6. Okay, so then we'll have moles over liters, which is a fine unit to use, moles/liters, or you could just do big M. So when I do this division here, 2.5 times 10 to the negative 7th divided by 0.0180, I get 1.39 times 10 to the negative 5th big M, which is moles over liters. Okay, continuing on down about maybe a fourth of the way down the page of page 6 on the white paper, we are going to calculate the rate for all 7 experiments, all 7. So remember that the formula for calculating rate from the beginning of this unit is negative change, that's what triangle means, is change in the bromate ion over change in time. Remember, this negative is not used in our calculation. It just represents the fact that our reactants, that this is decreasing over time, that these are being consumed and decreasing over time. So here's an example. You're going to take the number we just got up above on the top of page 6, and you're going to divide by your average time for experiment 1, your average time for experiment 1. So this number right here, the top number, will be the same for all 7 experiments. The bottom number will be different, assuming that the times have changed for the 7 experiments, which they should have. So you're going to take whatever we just had at the top of page 6, divide by the time that you have recorded, average time you have recorded back on page 2 in the data table. You're going to show your work. Remember that the units here should be moles over liters, and the units here should be seconds. So your unit in the end of your answer should be moles, liters, seconds. Moles over liter seconds. So you should be putting in units and everywhere that you have a number. Again, you're going to do this for all 7 experiments. I just kind of quickly wrote down 1 through 3, but you're doing it for all 7. Once that is done, we will go on to page 7.